In this video, we're going to continue talking about conic sections, and we're going to talk about a subject that we actually discussed when we discussed quadratic equation, and that's the parabola. And a parabola is one of the conic sections. If you were to, and this, I think this actual plane here needs to be slanted a little bit more, but if you slant to where you cut through only one of the plane or one of the cones here at an angle, you end up with this cross section known as a parabola. By definition, a parabola is a set of all points such that each point is equidistant to a fixed point called a focus and a line called a directrix. So you see here in this parabola, you see your directrix here, you see your focus. Every point on this parabola is the same distance from the focus as it is from the directrix. So if you pick a point here, the distance from the focus to that point and the directrix to that point is going to be the same. And the same over here. This distance will always be the same. So therefore, D1 in that figure, D1 and D2 would be the same distance or be equal for all points on this parabola. There are two types of parabolas. There is a vertical parabola that's either going to open up or down. And there's going to be a horizontal parabola that's opening left or right. And again, you see here again the directrix, and here's the focus for each of those. There's the focus, and here's the directrix. The focus will always be inside the parabola, so the parabola kind of bends around that focus. The directrix will always be outside the parabola. In addition, the directrix, and what we've learned about a parabola in the past, the axis of symmetry will always be perpendicular. Here, reminder that the axis of symmetry, which we learned in previous chapters, the whole negative b over 2a line, will always be perpendicular to that directrix. The vertex is always, we're going to use a different unit this time. The vertex will always be p units away from the focus and directrix. And we understand that distance because we said the distance from the focus to the parabola and the directrix to the parabola is going to be the same. So here, the distance from here to here has to be the same as the distance from here to here. We call that distance p, and you'll understand when we see the formula why we call it p. Okay, this first form of the parabola, again, we saw back when we talked about quadratics. First form of the parabola is y equals 1 over 4p. And you're going to see this different in different books and different websites. Y equals 1 over 4p times x minus h squared plus k. And I write it like that because that looks more like the form that you've seen in the past. Now, if we switch the x and y and the h and k, your second form of the parabola, x equals 1 over 4p times y minus k squared plus h will be the other form of your parabola. Okay, opening up and opening down. If we're going to open up, it all depends on this p value. And we've talked about before, let's talk about this. Y equals ax squared plus bx plus c. That was the form that you're more used to. That's the quadratic form. And we always said if this a value out front is positive, then it opens up, or negative, it opens down. Or you might have seen the actual formula written like this before, to where if this a value is positive, it opens up, and negative, it opens down. But however, that a is the same thing as this 1 over 4p here. And what forces that a to be positive or negative is this p value here. Your parabola is going to open up if p is positive. Your parabola is going to open down if p is negative or less than 0. Same thing over here. It's going to open right if p is positive, and it's going to open left if p is negative. Okay, the actual process of graphing a parabola, we're going to write the equation in the standard form above. We're going to determine the type of parabola, graph the vertex. We're going to solve for p to determine the direction of the opening, and also that p is going to tell us how far we are from our focus and directrix. It says sketch the parabola. We might, before we're able to sketch a good parabola, it's a little bit different from these other graphs we've been able to do. You might have to find some points. You might have to plug some x or y values in and to get some actual points on these parabolas to get a better looking parabola. Okay, first problem. It says negative 8y is equal to x squared. And again, to get it in the form that I like it better in, I like either y equals or x equals. Anytime you have x squared, this is going to tell me my parabola is going to be either up or it's going to be down. So let's get it in the form. Now let's get y by itself by moving this negative 8. Since it's being multiplied, we're going to move it to the other side by dividing. So we have now negative x squared over 8, but I don't want to leave it like that. Our form is y equals 1 over 4p times your x stuff. So therefore, instead of writing this as negative x squared over 8, let's get into a habit of writing it on these problems as negative 1/8 x squared. So now you have it in this exact same form. To figure out what your p-value is, we simply take what's in front of our x squared and we set it equal to 1 over 4p. So we've got 1 over 4p is equal to negative 1 over 8. It's a proportion. Move the 8 up here, move the 4p up here. It gives us 8 equals negative 4p. So p in this problem is negative 2. Since p is a negative value, and we could tell already since the negative 8 was a negative value that this parabola is going to open downwards. So we're going to have this scenario. Our vertex, we look for any transformations, such as if there was x minus or plus a value in parentheses, or a plus or minus value tacked onto the end of this, then we would have a transformation, but we don't. So we're going to have a vertex at 0, 0. So there's your vertex. Now the next two parts, your focus and directrix, is not part of the actual graph itself, but the distance to our focus and the distance to our directrix, we can take the absolute value if we'd like to, but that distance will be 2. Since it's a negative value, the focus will be here. You put an F there. The directrix will be up to, and it is a line. So your axis of symmetry it asks for also is going to be this line, which passes through your focus and is always perpendicular to your directrix. So let's label all these. Your axis of symmetry is going to be the line x equals 0. Your focus is located down 2 units from your vertex, so it's going to be at 0, negative 2. Your directrix is going to be y equals, and it's going to be up 2 units. It's going to be y equals 2. Now to actually graph this parabola, we can pick some points. Here's my equation right here. So let's pick some points. Let's plug those points in to get me a better looking parabola, and it can be any point that you want. I'm going to pick maybe 4 because I notice when I square it, I get 16, and I can do negative 1/8 times 16 really easy. So when I pick 4, I get negative 1/8 of 16, which is negative 2. So plugging in 1, 2, 3, 4 gives me negative 2. Since I have an axis of symmetry here, I know I've got a point also over here at negative 4, negative 2. You can pick some more points if you'd like to, but I'm just going to go ahead and connect my dots. My parabola will look something, and these don't have to be exact. You can get more points if you'd like to get it more exact, but it'll look something like that. Okay, number 2. You have y squared equals 6x. First thing we need to do is move that 6 over by dividing by 6 or multiplying by 1/6. So we've got 1/6 y squared is equal to x, or you can list that x first. Since you have x equals y squared stuff, then you're going to have either a left or right facing parabola. It's going to look like one of those. To figure out what the p-value of the parabola is, we're going to do 1 over 4p is equal to 1/6. Solving that, you'll get a p-value of 1.5. Since the p-value is positive, then it's going to face to the right. It's going to look like this. Your vertex, you're going to look for any pluses or minuses on your y and x values. Since you don't have any, you will have a vertex of 0, 0. So there's my vertex. Next up, since your p-value is 1.5, you're going to have your focus is going to be 1.5 units to the right, which will be, let's do it in a different color since it's not on your parabola. So there's your focus. That's going to be at 1.50. Your directrix is going to be left 1.5, which will be somewhere right in there. So it's going to be x equals, since it's a vertical line, x equals negative 1.5. Your directrix, or excuse me, that's your directrix there. X equals negative 1.5. Your axis of symmetry will pass through your focus and through your vertex. It's going to be a horizontal line, so it'd be at y equals 0. So there's all the different parts, and the only point right now that you have on your parabola is your vertex. So to find other points on the parabola, you got to be careful with this. You have your x and y values, and you can actually plug it back into this original, which looks a little bit better to me. And let's see, and I tell you a really good x value to plug in here would be 6, because then you have 6 times 6 is 36. So y squared is 36, so that means that y would be positive or negative 6 when you solve that. So when you plug in, and that should be the only value that I need, when you plug in 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, you get 1, 2, 3, 4, 5, 6. Or because of that axis of symmetry, 1, 2, 3, 4, 5, 6. So there's your two values, and then you can use those to draw your parabola. It'll look something like that. Number 3. Now this one has been transformed a little bit. This one, let's see, you want to move your negative 4 over. I like it in this form better. Moving the negative 4 over, it gives you negative 1/4. Y minus 2 squared equals, and if you would like to, now here's an option. If you'd like to leave your minuses and that -3 over there with your x, you can actually use the same mind thought, or the same mindset as you did on your previous problems. Those two things translate your vertex. The -3 would move it right 3. The -2 would move it up 2. Right 3 up 2 would be your new vertex. If you would like to move it, you can't really move the -2, but if you'd like to move that -3 over here by doing +3, what you need to remember is this k value, this transformation is going to move it. Now, since x is solved for here, this would move it either right or left. Since it's not over here with your x, it moves it exactly how it says it does. It would move it right 3. The -2, since it is with the y inside of parentheses, would move it backwards, which would be up 2. So this would be right 3 and up 2, but I like leaving it like this, because that transformation makes more sense if it's inside of those parentheses, because then it looks more like your circles and ellipses and hyperbolas. Your 1/4 p-value is right here, so we can say that 1/4 p is equal to negative 1/4. And it's going to be very easy to see that p would be -1 there without even solving it. Since your y stuff is what's being squared, that's going to be a left or right parabola. Since p is a negative value, then that's going to be the left parabola. Your vertex is again at 3, 2. So there's the vertex. We can do our directrix and focus really easy. Since p is -1, that means our focus is going to be now inside of the parabola on this side. Our directrix is going to be here. So therefore, we have a focus at left 1 from there. That's going to be 2, 2. We're going to have a directrix, a vertical directrix, so it's going to be x equals a number, and that number will be at x equals 4. Your axis of symmetry, it's going to be right here, that passes through your focus and passes through your vertex. That axis of symmetry is going to be at y equals 2. because again, if it passes through the vertex and the focus, it has to have the same y value there. Now let's find some more points on this parabola. Since this parabola bends this way, it would be pointless to plug in anything on this side. So let's plug in values to the left, which you're talking domain here, values to the left of 3. You can plug in 0 might be an easy one to plug in, just any x or y value here that you would like. Let's plug in 0 just to see what happens. You have then y minus 2 squared equals -4 times -3, which is 12. And that's going to give us a decimal answer, but that'll be fine. You can do, tell you what, let's just, to get rid of a square, we're going to square root, so we got to do plus and minus the square root of 12. It might have actually been easier to plug in y values here, and we'll do one in just a second just to show you. So your two y values here, move the minus 2 over by doing plus 2. So your two y values would be 2 plus and minus root 12. You can simplify this, but we're about to turn it into a decimal anyway, so I wouldn't worry with simplifying. Okay, the two y values I got there when I plugged in 0 was negative 1.5, which is somewhere right in here, and 5.5, which is 1, 2, 3, 4, 5.5, somewhere right there. And you see the symmetry across that axis of symmetry there. And like I said, let me show you something. It might actually be easier on this to plug in y values, especially a y value like 2. Because all your action is happening over here. You're subtracting and you're squaring. So if you plug in a y value, it's going to be easier to do that work. So you have 2 minus 2, which is going to be 0 squared, which is 0 equals -4 times x minus 3. You can get rid of -4 by dividing by it. 0 divided by -4 will be still 0, and you get rid of -3 by doing +3, and you're going to get 3. So another value on your graph would be 3, 2. Well, that didn't help much because that's actually my vertex. But just to go to show you that you can plug in y values as well as x values. But here is your actual parabola. We'll just sketch it from there just to see about what it looks like. There's the parabola. Number 4. Again, you can go ahead and get all your transformations for your vertex. That's going to be the stuff inside the parentheses with your x and y. If it's inside parentheses, it's backwards from what you would think. So -1, -2 automatically is going to be your vertex. There it is. Next step, I would get my 14 away from the y plus 2. And you can even write it like this. You've got 1/14 x plus 1 squared equals y plus 2. Now that you've taken care of your vertex and you know what your transformations are, if you'd like to go ahead and move that plus 2 over, you're going to get y equals, I'm going to write it on the left side now, 1/14 x plus 1 squared minus 2. So there is your standard form of this. Again, the plus 1 moved it left 1, the minus 2 moved it down 2. That was the vertex. The 1/14 is going to be your 1/4 p-value. Solving that is going to give you a p-value of 3.5, which is positive, which we already knew was going to be positive because the 1/14 was positive. So this is an x squared parabola, and x squared parabolas, it all depends on where the squared's at. X squared parabolas are up or down. Since p is positive, it's going to be an upward shaped parabola. So therefore, you have your focus and directrix. Your focus is going to be up 3.5, which is 1, 2, 3.5 right in there. Your directrix is going to be down 3.5, 1, 2, 3.5, which is somewhere right in here. So let's go ahead and do our focus and directrix. Your focus up 3.5 will be at -1, 1.5. Your directrix, which is down 3.5, would be y equals, because it's a horizontal line, -5.5. Your axis of symmetry will pass through both your, and I can draw it right here. Your axis of symmetry will pass through your vertex and your focus. It's going to have the same x value as both your focus and your direct vertex, which would be x equals -1. Now let's find a few more points here to complete your parabola. And again, plugging it into this, your x value is going to be easier to plug in. Obviously, I made the mistake on the last one. Don't plug in -1 because that is your vertex. So let's pick a different x value, maybe 6. Because when I do 6 plus 1 is 7, now squared it gives me 49. So that'd be 1/14. Let me change colors. 1/14 of 49 minus 2. Cross cancels, which leaves you with a 2 and a 7. That'd be 7/2, which is 3.5 minus 2, which is 1.5. So when I plug in 6, I get 1.5. So let's plot that. 1, 2, 3, 4, 5, 6, 1.5. Because of your axis of symmetry, you can also go the same distance on the other side. I think that's a distance of 7. So go 1, 2, 3, 4, 5, 6, 7 on the other side and put a dot at the same height. And you can use those 2 dots to semi-complete your graph there. So your parabola will look something like this. Number 5. This one's already in the right form. Y equals 1/4 x squared. You can already tell your 1/4p, which is right here, gives you a p-value of 1. So this one will actually be pretty easy to work. Since it's an x squared parabola, that's going to be an up or down parabola. Since p is positive, that's going to be an up parabola. There's no plus or minuses on your x or y, so that's going to give you a vertex of 0, 0. Your focus, since it's an upward shaped parabola, is going to be above it, 1 dot or 1 space. And your directrix is going to be below it, 1 space. So there's your focus and your directrix. Your focus is going to be at 0, 1. Your directrix is going to be y equals -1. Your axis of symmetry, again, passes through your focus and your vertex. And that would be the line x equals 0. Now we're ready to graph. We have our vertex already, so we can pick any other x or y values. And again, I like to pick x values or y values that will kind of work out with my fraction pretty nice. If I pick 2, 2 to the second is 4, and then when I do a fourth of 4, I get 1. So picking 2 gives me 1. Using my axis of symmetry gives me a point on the other side as well. If you would like more points, 4 would be another nice point to pick. 4 squared is 16. A fourth of 16 will be 4. So when I pick 4, I get 1, 2, 3, 4. Using the axis of symmetry, 1, 2, 3, 4 on the other side as well. And we've got our parabola there. That's plenty of points. There we go. Number 6. This one's already in our form, our form that we wanted in our standard form, unless if you want to move that -3 over here by doing +3 to group that x with your 3 to see that transformation more clearly. The +3, since it's grouped with the x, will move it left 3. The +2 with the y will move it down 2. So there's your vertex at -3, -2. You can go ahead and plot that if you'd like. Now I'm going to go back to the original form of that. The 1/4p is located right here. So we're going to do 1/4p equals -1/10. Solving that is going to give you a p-value of -2.5. Since your y stuff is being squared, this is a left-right parabola. Since your p-value is negative, it's going to be a left parabola. So our parabola is going to be shaped this direction. To get your focus and directrix, okay, go left 2.5. There's going to be your focus. Go right 2.5. Your directrix will be somewhere right in there. Your axis of symmetry passes through the vertex and the focus. In there. Let's draw that back. So let's fill all this in. Your axis of symmetry is at y equals -2 because it passes again through that vertex. Your focus, we went left 2.5, so that'd be -5.5 2 or -2. Your directrix, we went right from here, -3, we went right 2.5. So that's going to be at x equals negative 0.5 is where your directrix will be. Now to get more points on here, again, we can go back to our original problem. A little bit tougher when you have the number in here squared, but let's see, we're about to have to take a tenth of something, which is the same thing as dividing by 10. So if I could get this to be some multiple of 10, it'd be nice because it would cancel with the bottom. So to get that multiple of 10, I don't know, but I think and notice what I'm doing here. I'm plugging in y values because all the action is happening over here, not with the x. If I plug in an x value here, I'm going to have to solve this equation like putting in an x, I'll have to move stuff over, multiply by negative 10, and all that work, to where if I plug in a y value, it's going to be much easier. So I'm going to plug in a y value of 3 because I notice when I do 3 plus 2, it gives me 5, and when I square it, it gives me 25. And it's I know it doesn't cancel completely, but a tenth of 25, it'll give me a nicer decimal. So when I work that out, let's see, that's going to be negative 1/10 of 25 minus 3 is equal to x. Negative 1/10 of 25, negative times a positive is a negative. A tenth of 25 will be 2.5. Negative 2.5 minus 3 will be negative 5.5. So it's not an extremely ugly decimal. So let's go left. 1, 2, 3, 4, 5.5, which is right there. Oops, I forgot to go up 3. And then from there, we'll go up 1, 2, 3. So there's 1 point. We can see how far we are from our axis of symmetry. 1, 2, 3, 4, 5 away. So let's go down 1, 2, 3, 4, 5 units down. And that gives us another point. And that will be plenty to actually draw our parabola. Number 7. Got a couple more problems. Now these, we're getting into a little bit more difficult ones. What we're going to do, I've got y squared and y stuff. We're going to have to do some completing the square here. I've got x stuff, but I don't have x squared stuff. If I had x squared stuff, it wouldn't even be a parabola. So what I'm going to do, I'm going to move my minus 16x over, and I'm going to group my y stuff. Y squared minus 2y equals minus 16x turns into 16x minus 33. We're going to complete the square here. That's the reason I left a space. Because y squared stuff mixed with y stuff, half of negative 2 squared gives me a plus 1. If I add 1 to that side, make sure you add it to both sides. This, anytime you complete the square, your next step is to always try to factor. That's going to factor into y minus 1 times y minus 1. The other side turns into 16x minus 32. Now here's what you're going to want to do is we don't want any numbers in front of our x, or if this was a y. We're going to actually factor this 16 out so that we can see that transformation. So when you factor out a 16, you're going to see it starting to look more like what you're used to seeing. The only difference is normally your number, the 1 over 4p stuff, is written out in front of the x squared or y squared stuff. So we're going to move that over by doing 1/16 y minus 1 squared equals, and I'm going to leave that x minus 2 over here, and I'll even put it in parentheses because that shows you your transformation. This is right 2, up 1. So your vertex is going to be at 2, 1. Now, if you would like to move that minus 2 over, those parentheses, again, are really not even necessary. You could write this as 1/16 y minus 1 squared. To move minus 2, you're going to do plus 2 is equal to x. So there's your standard form. You can see the transformation happening there. Here's your 1 over 4p. So that'd give you a p value, obviously, of 4, because if 1 over 4 times p is equal to 1 over 16, in order to make that true, then p would have to be 4. Since you have a y squared parabola, it's going to be either left or right. Since your p value is 4, it's got to be a right-shaped parabola. So we're going to go to the right 4. 1, 2, 3, 4 to get our focus. We're going to go left 4 to get our directrix, which would be right here. Let's go ahead and label those. Right 4 would be at 6, 1. It would be your focus. Your directrix, left 4 from 2 would be at, it's not a point, X equals from 2, left 4 would be -2. Your axis of symmetry passes through, once again, your vertex and your focus. Look at your vertex, look at your focus. They both have a y value of 1. So obviously the line that passes through both of those will be y equals 1. Now to find other points on this parabola, let me get some of these boxes or circles off. We can plug in anything but a y value of 1. Plugging in a y value of 1 here would actually give you your vertex back. So let's see, we've got to take 1/16 of it. I know I can take 1/16 of 16 would be nice. So if I plug in a 5 here, 5 minus 1 is 4. When you square 4, it gives you 16. So let's plug in. That would be a y value that we're plugging in. So plugging in a y value of 5. Let's do that. 5 minus 1 is 4. 4 squared is 16. 1/16 of 16 would be 1. And then when you add 2 to that, it gives you 3. That came out really nice and neat. So when I plug in 1, 2, 3, I get 1, 2, 3, 4, 5. Using the axis of symmetry, that is 4 units away. So let's go down 4 units, and that's going to give me another point. So my parabola is going to be fairly wide, shaped right there. It looks something like that. Then the last one, we're going to have to do some more completing the square here. So I'm going to leave my x squared plus 10x together here. My 4y and my 1, I'm going to move to the other side by doing -4y minus 1. To complete this square, we're going to half and square. That's going to be plus 25. So let's do that to both sides, and we will be able to combine those. When you factor that, that's going to be x plus 5 times x plus 5. Go ahead and factor, well, we can go ahead and rewrite that if you'd like. -4y, -1 and 25 would be a positive 24. We're now going to factor that -4 out to make it look like more like our form that we're looking for. -4 times y minus 6. Now you see all your transformations happening. The -4 gets moved over by doing -1/4. X plus 5 squared equals y minus 6. And again, that plus 6 or minus 6 can be moved over by doing plus 6, but we'll leave it for just a second so we can get our vertex, which is at -5, positive 6. Now, if you would like to move that minus 6 over by doing a positive 6 on the other side, that will be fine. So there's your standard form. So -5, 6. Let's go ahead and write that. -1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There's going to be your vertex, your focus, and your axis of symmetry. Okay, your p-value here is -1/4. So that means that p would have to be -1 once you solve it. Just set that equal to 1 over 4p and solve. So if you have a p-value of -1, that means your parabola is going to be, since it's an x squared parabola, that's going to be a downward shaped parabola. So there's your focus. There's your directrix, a distance of 1 away. Here's your axis of symmetry. So you have an axis of symmetry at x equals -5. You have a focus at -5, comma, we went down 1, so that'd be -5, 5. You have a directrix at y equals, we went up 1 from 5 or 6 to y equals 7. You can check that 1, 2, 3, 4, 5, 6, 7. That's right. We now need, and I'm going to erase some of this so I can plug some values in. We now need to plug some stuff in, and point out here that I'm going to be plugging in x's because it's going to be easier to clean up if I plug in x's. And again, the way I think about this is, what can I take a fourth of? Pretty easy. That I get once I square it. I know I can take a fourth of 4 really easy. So how could I make this a 4? Well, if I square a 2, that's going to give me a 4. So let's say I can plug in a -3 maybe. So let's try that. When I plug in -3 for my x, when I add 5, I get 2. When I square it, I get 4. When I take a fourth, negative 1/4 of 4 gives me negative 1. Negative 1 plus 6 is 5. So when I plug in negative 3, negative 1, 2, 3, I get 1, 2, 3, 4, 5. Using your axis of symmetry gives you another point right here. Let's plug in some more values. Let's see. I know that I can take a fourth of 16, so if this was 4, that'd be pretty easy. So let's plug in a negative 1. Negative 1 plus 5 is 4. 4 squared is 16. Negative 1/4 times 16 is negative 4, and negative 4 plus 6 is 2. When I plug in a negative 1, I get a 2. Using your axis of symmetry, 1, 2, 3, 4, 1, 2, 3, 4. Gives me a dot right there as well. So therefore, there is my parabola.